Come with me to predict the future. I can help you understand the past. And I can help you do both. Wake up, babe. New model dataset just dropped, and it is hot. This video is about modelling in Antarctica. And no, I don't mean Naomi Campbell on an ice sheet. In a new paper, myself and colleagues have shown that our new model data is now the best in the biz for predicting the future climate of Antarctica. Which is pretty badass because Antarctica is changing before our very eyes with knock-on impacts for the whole world. This is not the sort of thing I would usually make a video about because modelling is kind of technical and this work is actually mostly a data product, which on the surface doesn't sound that exciting. But I genuinely think this is very cool because it represents a step advance in our ability to understand and predict the climate of the polar regions, which obviously matters a lot. And it's also the product of the project that finished me off in academia, so it would be rude not to talk about it. Antarctica is a part of the world where there are relatively few observations, especially of things like snowfall or ice melting or cloud properties, and that means it's actually quite hard to get a clear picture of the current climate. So we rely a lot on model simulations. Models include all of the known relationships between things like temperature, winds, precipitation, ice melt, and literally everything else that we observe in the real world. We write those relationships into maths and into code and then let them interact, which replicates how things happen, out there. We can use these models like a tiny experimental world where we can play around with different outcomes. If we feed the model data from the past, then we can test if they can get the present right. And then if they pass that test, then we can use them to predict the future. Luckily, they pass with flying colours. The kind of models that I ran when I worked in academia were the kind of models that we use to forecast the weather. And they run on exactly the same principle. You feed the model information about what has already happened, and then you get it to predict what will happen in the near future. And despite how much people moan about them, they're actually pretty good at doing it. This project, called PolarRes, was using a variety of these kinds of models to predict the future of the Arctic and Antarctic up to 2100. Variety is the spice of life, as they say, and in model world, variety helps us understand the possible range of futures that might occur. These are actually the same suite of models that I used to show that it's raining in West Antarctica, which I talked about in this video up here. In this new paper, myself and my colleagues comprehensively evaluated how well those various models are capturing the climate of Antarctica over the recent past. And, spoiler alert, they're doing pretty good. They're pretty arguably better than the next best option, and most importantly, we can use them to predict the future. Part of the reason they're better is because of their resolution. Think of the difference between watching YouTube on grainy 144 to clear HD. You can see and understand so much more. Resolution matters because the climate of the polar regions, and Antarctica in particular, is really sensitive to local features like terrain. Here's why. Antarctica is a polar desert. It's cold, it's dry, very little snow falls there. Almost all of the snowfall happens around the edges of the continent, where the terrain slopes upwards very dramatically and steeply onto the ice sheet, with virtually zero happening on the cold, high, and dry continental interior. The altitude and terrain also impacts things like temperature, wind, and ice loss. That means that the terrain around the edges is very important. So if we want to accurately model Antarctica's climate, then we have to get the terrain right. That requires fidelity, detail, and resolution. The maths that represent the real world in models is necessarily a simplification of reality, but the higher the resolution, the higher the level of detail, and that can improve the way important processes and relationships are represented. That's true for all elements of the polar climate, but it is especially true when we're talking about terrain, localized wind patterns, clouds, and precipitation. This new model dataset is at a much finer resolution, meaning it has much more detail and definition than any other available dataset. It means scientists can use this as a tool to understand the recent past, as well as the next century of changes in Antarctica. The other reason these data are better is because they include more sophisticated representations of the Antarctic climate. These models have more components that are specific to the polar regions. If you're forecasting the weather in England, chances are you probably don't need to think about the ice sheets. But if we're talking about Antarctica or the Arctic, then we most definitely do. These models are designed to perform best in the polar regions. And as a result, they are capable of capturing the Antarctic climate far better than any generic weather model. The long and short of it is that these data are the best in the business for understanding the recent past, present, and near-term future of the polar regions. My colleagues are actually already using the data that goes out to 2100 to evaluate how climate heating is going to transform the Antarctic and Arctic. The work that is coming out of this project using this data is genuinely transformative and will give us so much more insight into polar change, allowing us to plan for and adapt to what's to come. There is so much more that can be done with these data and so many different questions that could be answered. One study done by my pal Marta, who you may actually remember from this video up here, is looking at how ice shelves in the Antarctic are likely to melt over the coming decades as a result of temperature rise. I'm sure I'll make a video about some of the work that comes out of this project once more of the studies are actually published. So make sure you are subscribed so you don't miss out. Thanks for watching this video. If you are a climate and/or data nerd and you want to play with the data or use it for any scientific purposes, then it is freely available and I highly recommend using it. Data links are in the paper and I will also stick it down here. And they'll also be searchable on the Earth System Grid Federation network very, very soon. If you are not a data nerd, but you still want to learn more about polar climate change, then check out this playlist of all my polar science videos over here. And if you'd like to support the channel, you can become a member here or sign up on Patreon using this link. All the subscriptions go into making this channel bigger and better with every single video. Thanks.